Good morning, Ekta, Shrutika, Sharmila, Kanishka. Good morning, beta. Divyashri, good morning. So last class in structure of atom, we were talking about cathode ray experiment. Rahul, good morning. We were talking about cathode ray experiment. And in that we have discussed how cathode rays are exactly having what? They are exactly containing material particles that these material particles are negatively charged and they are called as electron. Okay, so now we are going to study the next part of it. Here, one last part we have not discussed, because now charge and mass of electron is very, very important. Okay, what is an electron, what is charge and mass of electron, and how charge by mass has been derived. That is another important point to discuss. Fine. Send the link in the group and tell everyone. That will be very difficult for them to understand if they will not be joining class now. Okay. So now charge by mass. So charge and mass of an electron. This is a very, very important thing we are discussing today. Now charge by mass or charge and mass, how it has been derived. So first excuse me. To derive it or to determine it, for determination of ratio charge by mass. Charge by mass. How to derive charge by mass? This was exactly done by, and charge by mass of whom? Charge by mass of electron. It was exactly done by J.J. Thompson, and he used a special type of discharge tube to get charge by mass. Okay, to get a special type of discharge tube he has used to get charge by mass. A special type of what, beta? A special type of discharge tube he has used to get charge by mass. Okay, now what he has done? He studied, and in the year, which year he has exactly done this experiment? In 1897. In 1897 he has done that. He studied the extent of deflection of cathode rays under the influence of electric and magnetic field. So we discussed yesterday itself now कि if a discharge tube we have taken, and in that discharge tube if electrical field we have applied, then the cathode ray is getting deflected. And that time Shruti has asked this question now, कि why we have taken a hole in the anode. So that time I told you now how much extent of deflection will be there. That extent of deflection will be exactly calculated. That extent of deflection was measured. So that is what it is written, that the extent of deflection under the influence of electric and magnetic field of different strength, it has been calculated, it has been measured, and he determined the ratio of charge by mass of the particle constituting the cathode ray, and with the help of that deflection only he exactly found the charge by mass. Okay, this is usually represented by E by M. Charge by mass is represented by E by M. E represents the charge and M represents the mass. And after calculation, he came to the conclusion that charge by mass is 1.76 into 10 to the power 11 kg, into 10 to the power 11 coulomb per kg. 10 to the power 11 coulomb per kg. Charge by mass. How he did? charge by mass. How he did? He exactly used this experiment. You see, the deflection experiment he has used. So where anode was exactly perforated, a hole was there in the anode, and it has allowed current, cathode ray to pass through it. The extent of deflection in the presence of electrical or magnetic field. I repeat, the extent, Krisha, good morning, beta. The extent of deflection in the presence of electrical or magnetic field he measured, and after measuring it he came to one conclusion that he came to the conclusion charge by mass he got is, what is the charge by mass he got? 1.76 into 10 to the power 11 coulomb per kg is the charge by mass he got. How much he got? 1.76 into 10 to the power 11 coulomb per kg is E by M he got. Come on, everyone, tell me quickly, did you understood this point? Did you understood this point? Yes, E by M is coming as, absolutely correct Sharmila, E by M is coming as 1.76 into 10 to the power 11. 1.76 into 10 to the power 11. This is exactly charge by mass. This is exactly what? This is exactly charge by mass he got. Charge by mass. Absolutely correct. Okay, understood Ekta? So now after that we are going to understand that now charge by mass to we got. But I told you that there are two important points of electron. Means we must know electron by two important things, and that is charge and mass. But J.J. Thompson has exactly taken out charge by mass. Okay, he took out what? Charge by mass. Vishal, good morning beta. He took out what? He took out charge by mass, but J.J. Thompson part charge by mass. Then we are going to find only charge. So it was done by Milikan experiment. Milikan has done an experiment on droplets, oil droplets. Okay, so I'm just repeating, Milikan was the scientist who has done experiment in the year 1917 by oil droplets. Okay, and with the help, Jiva, good morning beta, with the help of that experiment we got charge of electron. With the help of that experiment, what we got? With the help of experiment we got charge of electron. I repeat, with the help of experiment we got charge of an electron. So how we got charge of an electron? Let's see. So with the help of his oil drop experiment, in this experiment oil droplets were charged by capture of electron. So oil droplets were charged by capture of electrons. So what he did is he just charged the oil droplets, which is exactly having electrons. Okay, the charge on the droplets was found by nothing the charge of the droplets was found by noting the speed at which they moved between two plates of electric field. So the charge of that electron, it is exactly found by calculating that between two electrode plates that electron movement is there now. With the help of that only they tried to know the charge of electron. Okay, I am repeating, the charge on the droplets was found by noting the speed at which they moved between the two plates of an electric field. Between the two plates of an electric field of a particular strength. So one particular strength electric field he has taken, and the movement of that charged droplets the movement of that charged droplets in that electric field, the speed of that was calculated, and by good morning Avinash, the speed of that was calculated, and that was exactly capable of giving us the charge of electron. Okay, so it was found that charge on the droplet was always multiple of elementary charge, means every time they calculated and every time they got that 1.6 into 10 to the power minus 19 coulomb. That was the fixed charge on electron. See, experiment was simple. I am repeating the experiment one more time. Exactly what he has done there, that key oil droplets were taken. So these oil droplets were charged, means electrons were there. Now two electric plates are there. In between the plates, this droplet movement, by changing the amount of current, By changing the amount of current, they tried to know the speed. With the help of the speed of the movement of the droplets, he exactly kept on capturing that what could be the charge of electron. So every time, at the time of measuring the charge, no matter how much amount of current is exactly changing, current has been measured, but every time the recording was same. The recording was 1.6 into 10 to the power minus 19 coulomb. How much it was? 1.6 into 10 to the power minus 19 coulomb. I hope everybody understood what was the charge there. Every time the charge was 1.6 into 10 to the power minus 19 coulomb. Maybe this story you will be forgetting, that how this charge has been invented, how this charge has been, we got the charge, but just remember the name of the scientist, that is Milikan 1917. Milikan 1917, he has done this experiment with oil droplets. Okay, these oil droplets were charged. The oil droplets were what? The oil droplets were charged, allowed to move between two plates, electric plates, and by changing the amount of current, every time the current strength they kept on changing. But one thing they found, that the speed of the droplets they have exactly measured, and they found that the charge of the electron, with the help of that speed, they noted the charge of the electron was exactly 1.6 into 10 to the power minus 19 coulomb. Okay, the speed at which they are moving between the plates, they have noted that one, but every time they have exactly seen one common thing, and that is charge by that is electric charge is coming as 1.6 into 10 to the power minus 19 coulomb. It is the smallest quantity of charge that could be measured, hence it is called as 1 unit charge. So this is 1 unit charge of electron. This is a very major point. So this is the smallest unit. This is what? Not largest unit. This is exactly the smallest unit of measurement, and that's what it is called as 1 unit electric charge. I hope you might have understood this point. 1 unit electric charge. 1, I repeat, 1 unit electric charge. 1 unit electric charge. What is 1 unit electric charge? 1 unit electric charge is 1 unit charge, or electric charge means what? 1 unit charge is exactly coming how much? 1.6 into 10 to the power minus 19 coulomb, and these electrons, we know already they are negatively charged particle, so we can say that electron carries 1 unit negative charge. 1 unit negative charge. How much unit negative charge? 1 unit negative charge. I hope you might have understood this point. So 1 unit negative charge it is containing. Now let's talk about this 1 unit negative charge. Okay, so 1 unit negative charge we have seen. Now it is time to get the mass of electron. Yes beta, Krisha, 1 unit charge, and 1 unit charge is coming how much beta? 1.6 into 10 to the power minus 19 coulomb. That value you have to remember, 1.6 into 10 to the power minus 19, that is 1 unit, correct Avinash? So 1 unit we were talking about, and that is exactly coming as 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb. So today where is Kanishka, Darshani, Divyashri, Ashwarya? I will not teach like this. I will not at all teach like this. If they think that they can sleep right now, they can rest right now, and I will be teaching, that is not going to work with me. Now we are going to see another important point, how to get the mass of electron. So now we have two conclusions. One is J.J. Thompson experiment. In J.J. Thompson experiment, we saw charge by mass. In J.J. Thompson experiment, what we have seen? In J.J. Thompson experiment, we have seen charge by mass, E by M. And in Milikan experiment, we got charge. And in Milikan experiment, we got charge. Now we have both the values. We have both the values. We have the value of charge and we have the value of charge by mass. Now if we will exactly shift it in such a way, we can be able to get the mass of electron. So our most important strategy here is to get the mass of electron. What we have to get? We have to get the mass of electron. So how to get the mass of electron? So we have to do only one thing, that is charge by mass. So what is the charge? Charge given is 1.6 into 10 to the power minus 19 coulomb, and charge by mass is 1.76 into 10 to the power 11 coulomb per kg. So it is exactly after calculation. So it is exactly going to give us mass. It is going to give us mass. That is charge by mass. This mass will go up. So it will become mass. So mass is equal to 9.1 into 10 to the power minus 31 kg. Remember this one. This is the smallest mass, smallest. So what is the mass of electron? The mass of electron is 9.1. How much is the mass of electron? 9.1 into 10 to the power minus 31 kg. 9.1 into 10 to the power minus 31 kg. So we got three important values. First important value was charge. That is 1.6 into 10 to the power minus 19 coulomb. Then we got charge by mass. 1.76, okay, into 10 to the power 11 coulomb per kg. Then we got mass now, and mass is 9.1 into 10 to the power minus 31 kg. And you have to remember one very important point, that ki now in future in class 10th, 11th, 12th, higher classes, you have to remember these two values. What two values? Charge and mass. So this is the most important thing. That is the charge of electron. What is the charge of electron? In class 10th also you will be using it. So charge of electron is 1.6 into 10 to the power minus 19 coulomb. So this is exactly the charge of electron. The unit of charge is coulomb. What is the SI unit of charge? SI unit of charge is coulomb. Okay, COU, coulomb. SI unit of charge is coulomb. What is the SI unit of charge? The SI unit of charge is coulomb. So charge of electron is 1.6 into 10 to the power minus 19 coulomb. The SI unit of charge is coulomb. Now next we are going to study is mass of electron. So mass of electron is exactly 9.1 into 10 to the power minus 31 kg. Mass of electron is 9.1. Yes, coulomb is the SI unit of charge. In class 10th, when you will be studying in class 10th, that time you will understand that C stands for coulomb. What does C stands for? C stands for coulomb. Kanishka asked me in evening itself, beta, that is what is the timing. Timing will be now fixed. Morning this will be the timing, and evening timing will be 4 o'clock. Now that is fixed, beta. 4 o'clock means 4, 5, 4, 10 will happen sometime, but mostly evening time will be 4 o'clock. Morning time will be this time only. Okay, and offline classes timing I am going to send soon. So mass of electron I said I will send soon. Okay, so that information I will give you. So now just look here, what is the mass of electron? These values are going to be with you when you will go in higher classes. So these two values are very, very important. What are the two values? Mass of electron, that is 9.1 into 10 to the power minus 31, and charge of electron 1.6 into 10 to the power minus 19 coulomb. So these two are very, very important thing. Okay, I hope you might have understood this point. Shall we go back to our next point? And that is origin of cathode rays. So charge of electron, electrons are negatively charged. Charge of electron is 1.6 into 10 to the power minus 19 coulomb. Now how to represent, what is the symbol of electron? What is the symbol of electron? the symbol of electron is, basically you will be seeing that people are presenting electron like this, e to the power minus they are writing, and they are presenting electron, but symbol of electron is represented as -1 0. This is exactly the symbol of electron. Minus base will have -1 and power it is exactly written 0. So this is nothing but symbol of electron. This is nothing but symbol of electron. Symbol of electron is -1, 0 will be there, electron. This is exactly symbol of electron. This is what? This is symbol of electron. I hope you might have understood the symbol of electron. Symbol of electron is -1 0 electron. This is exactly symbol of electron. Symbol of electron. I hope you might have understood this point. Come on, quickly tell me if you have understood. We are going to go to the next point. This is symbol of electron. Electron is mostly presented as E minus. Understood quickly? Understood, Sharmila? Very good. So some children, they are very active. They are interacting with me. Some are sleeping. Means they came, they said good morning, and after that they started sleeping. Come on, let's see how many are sleeping and how many are awake right now. Jiva understood. This is Darshani's number, na? Shruti understood, Kanishka understood, Rahul understood. Super, very good. Sharmila present, I know beta. But some children are sleeping. I am going to wake them up in offline class. Direct oral test this time I am going to take. No written test, direct oral test. So let's see how much they are learning right now. Now another important point is कि if we got the mass of electron, then if we are getting the mass of electron, then if we are getting mass of electron, then can we compare the mass of electron with mass of hydrogen? Then we said that mass of electron is 1 by 840 times the mass of hydrogen. So if somebody told that how to compare mass of electron and mass of hydrogen, then we said that we can compare the mass of electron and mass of hydrogen. How to compare mass of electron, mass of hydrogen? So mass of one electron, mass of electron is equal to 1 by 1840 times the mass of one atom of hydrogen. Okay, this is a very important point. I know Kanishka, you are present, beta. So this is exactly the very important point. If somebody will be telling you compare Khushbu aunty mass and Sharmila mass, then you will be saying that it is easy to compare the mass of these two people. Then you will bring a balance and then you are going to find the mass of me and Sharmila. That is an easy thing, huh? But if somebody will tell you to compare the masses, then you will compare my mass, you will find my mass and you will find Sharmila's mass, and then you will compare. So now in the same way we compared mass of electron and mass of one atom of hydrogen, and we saw that mass of electron is 1 by, see this much less it is, 1 by 1840 times the mass of one atom of hydrogen. So less. Understood? Yeah, but I know Jiva is present. So less, this much less it is. Okay, so the mass of electron is 1 by 1840 times the mass of one atom of hydrogen. That means it is very less in compared to that of one atom of hydrogen. In compared to that of one atom of hydrogen. Till here everybody understood? We discussed about two experiments. One was J.J. Thompson experiment that we have already seen in the past. That is, they just tried to know the deflection of the deflection of cathode rays in electric and magnetic field. And after that we saw the next Milikan experiment, Milikan oil droplet experiment, and from there we got charge. One J.J. Thompson experiment we got charge by mass, Milikan experiment we got charge, and then we wrote charge by mass to get the mass of electron. And then we found the mass of electron is 9.1 into 10 to the power minus 31 kg. And then we saw the symbol of electron. Symbol of electron was -10, and electrons are specifically presented by e to the power minus. So these were the things we have seen till now. Now we have to exactly understand what is the origin of cathode ray, because now negatively charged rays were called as cathode rays. Negatively charged rays were called as cathode rays. So the cathode rays are first produced from the material of cathode. We have already known about it. We saw the experiment. Now these then hit the gas atoms represent in the discharge tube and knock out the electrons. These electrons travel towards the oppositely charged anode in the form of cathode ray. This was the experiment only we have seen. So they are telling that what is the origin of cathode ray, how origin cathode ray came out. Origin of cathode ray means how cathode ray came out. We took two electroplates, electrodes we have taken, and high amount of current has been passed. Then from the cathode part we saw a ray is coming out, and that ray was named as cathode rays. Since it is coming out from cathode, so it got its name cathode rays. And then we understood the properties of cathode rays. The properties of cathode rays were negatively charged. Okay, they have heating effect. They are material particles. They move in straight line. They have X-ray effect. All these important points we have seen, and they emit a specific type of light. So all these important points, that is fluorescent one, that is greenish yellow, all the point we have seen. So they were the properties of cathode ray. I hope my children might have understood till here. Now to conclude, electrons are exactly what? Electrons, here one very important point for conclusion I am discussing. I am not in hurry-burry. I didn't discuss anything in hurry-burry. I am teaching this chapter in much details, because once you will have interest in understanding this, in class 10th and 11th you will not exactly have more problem. Without any content you will be able to understand the things nicely. Okay, so now to conclude that electrons are constituent of all atoms, means कि now we should say that all atoms should contain electron. See, we know that atoms have charges. Atoms have charges, but what type of charges atoms are having, we have to fix that. So now we have concluded one thing, that atoms are definitely having negative charge. Not one atom, all the atoms, all the different type of atoms like hydrogen, helium, lithium, beryllium, all the different type of atoms are there, all have electrons. This conclusion is needed. All have what? All have electron. So one experiment, it was found that we may take electrodes of any material. So here we have to conclude this experiment. We have to conclude this experiment. So for this J.J. Thompson has proposed a very important point. He said that okay, take any material electrode, not of a specific material. So the electrodes we have taken now, and see, these two electrodes we have taken now. Now J.J. Thompson has proposed, or we have exactly seen one thing, that these two electrodes can be of any material. Okay, any material, any element they are taking, and they are telling that now these two electrodes can be of any material, and any gas, any different type of gases also we can take. And different type of gases we can take inside this chamber. So we have taken different type of gases, we have taken different type of electrodes. But one thing we have seen that is common, that that is common, that in every time cathode rays are only emitting. So cathode rays are only emitting, and this proves the point that each different type of atoms have one thing common, and that is presence of negatively charged electrons. Presence of negatively charged electron, and this is a very major conclusion we have drawn. So what is the major conclusion we have drawn? Come on, quickly tell me what conclusion we have drawn from this experiment. What conclusion we have drawn? So if somebody will be asking you what is the conclusion of what you have studied in yesterday's class and today's class, so what is the final conclusion? The final conclusion is that every atoms, repeat, you just note down this, every atoms have negatively charged subatomic particle, that is electron. Negatively charged particle, that is electron. So we call electron as subatomic particle. So that is another important point. So every atom I hope you might have understood this point. Every atom is having what? Sleeping monsters? Come on, tell me the answer. Every atoms have what? What is our conclusion right now? What is our conclusion we have drawn from the experiments from yesterday? We are discussing about it. Now come on, tell me what is the final conclusion we have drawn? Yes, that every atom has negative charge in it, and that is electron. Awesome work. So they have exactly what? They have electron. They have electron. Super. So this was the finding. So no matter what gas you are taking inside the discharge tube, no matter what material electrodes you have taken, you are always finding cathode rays are emitted. So by seeing that cathode rays are emitted, we fall into a conclusion that okay, every different type, because these electrodes we have taken, they are made with element only now. So every time we have seen that negative charges are exactly emitted, and that negative charge we have named as electrons. Okay, so further they didn't stop there only, because you know one thing, once you will do one experiment now, once Shruti will do experiment, I may approve the experiment of Shrutika. I'll say that Shrutika, you have done a very good work, but you know what, their friends, another teacher, another important person will come and they will ask a question. Hey, the experiment what she has done, how much it is proved? How much is it? It may have some fault. So everyone will find fault in that. So what they did, they tested it by different content, but every time they are finding that the charges are negative. Okay, the charges are negative. Now what they did, by strong heating of certain metal also they did, so that is photoelectric effect also they did. So after that also they have seen that electrons are negatively charged. By exposing active metal like sodium, potassium to ultraviolet rays, after that also they did like that, they exposed the most reactive metals, sodium and potassium, to ultraviolet rays, and there also they saw that the atoms are containing negatively charged particle. By exposing any form of matter to X-ray, they have exposed the matter to X-ray, there also they saw that the X-rays are releasing electrons. That is again they proved that electrons are negatively charged particle. By radioactive substance in the form of beta rays. So they did all the experiments to prove one thing, that atoms have negative charge, and these atoms negative charge is called as electron. Understood? Understood this point? So this negative charge is what, beta? This negative charge is nothing but electron. Come on, quickly tell me, did you understood this point? Did you understood this point? Understood now? So one more time, if you will have time, rewatch the video, because I discussed very important points today. So whatever from the starting part of structure of atoms now, I discussed the most important points, and these points are the bone of structure of atoms. So structure of atoms, if anybody has to understand, we have to understand these points, and they are very important, beta. So now we are going to talk about discovery of proton. Discovery of proton. So now electron discovery done. We know that atoms are having negative charge. But one thing is there na, each atoms are electrically neutral. The number of positive charge should be equal to number of negative charge. That was the point. But where is that negative charge? The big problem is, beta, where is that negative charge? Where is that positive charge? We are going to see that. That was a big problem. But now, here we have one conclusion that each atoms are electrically neutral. This word electrically neutral means, what does electrical neutrality means? Electrical neutrality means, electrically neutral means what? Electrically neutral means, electrically neutral means what? Electrically neutral means number of positive charge is equal to number of negative charge. Number of positive charge is equal to number of negative charge. That means each atoms are electrically neutral because now look here, my pen is electrically neutral. What does my pen is electrically neutral means? Means number of positive charge equal to number of negative charge. But suddenly what I did is I started rubbing the pen on my head. So now what happened? Two things happened here. CB, good morning CB. So two things have happened here. One thing is the pen acquired positive charge, my hair acquired negative charge. So exactly what happened? But here the number of charges were there, they were neutral. How many negative charge appeared? Same number of positive charge will appear. So that is the case of electrical neutrality. That is the case of what? That is the case of electrical neutrality. That is number of positive charge equal to number of negative charge. So we concluded another important point that every atoms are electrically neutral. I want everyone to type this or note down in your note. What is exactly I discussed that every atoms are electrically neutral. What does that means? Number of positive charge equal to number of negative charge. Number of positive charge is exactly equal to number of negative charge. I hope you might have understood this point. Understood? Number of positive charge is exactly equal to what? Number of negative charge. Number of positive charge equal to number of negative charge, and that is the meaning of electrical neutrality. What does that means? It is exactly explaining electrical neutrality. Electrical neutrality. So before invention of a proton, that was exactly known that every atoms are electrically neutral. Every atoms are what? Every atoms are electrically neutral. So presence of negatively charged electron in it, that means if it is electrically neutral, then number of positive charge should be equal to number of negative charge. So where is the positive charge? We should see the positive charge. Now we understood this concept, but we have not seen any positive charge there. Where is the positive charge? Where is the positive charge? Now we have to find where is the positive charge. So one experiment, Goldstein has done an experiment, that is the discharge tube experiment, to get the positive charge. And these positive charge were also called as what? Proton. And these positive charge, they have given the name called as proton. These positive charge were given the name called as proton. So now what he has done in this experiment, so I am just going to, it is a beyond doubt that there was thought that some positively charged particle must also be present in the atom. So the existence of positively charged particle in atom was shown by Goldstein in the year 1886. So Goldstein has done this experiment to get the positive charges in an atom. So now we are going to do this experiment to know the positive charge. So he took a discharge tube with a perforated cathode. Can you see this perforated cathode? Perforated cathode means beta there is hole in the cathode. You see this cathode, there is a hole in this cathode. That is exactly called as what? It is exactly called as perforated cathode. What it is exactly called as? Perforated cathode, because in this cathode electrode you can see that gaps are there. So for this experiment he has taken perforated cathode. He has taken what? I am repeating, he has taken perforated cathode, and after that what he has done? So and then a gas at low pressure was taken inside the discharge tube. So one gas has been taken inside the discharge tube, and that pressure of the discharge tube has been reduced. What has been reduced? Pressure of the discharge tube has been reduced. How to reduce the pressure of the discharge tube? With the help of a vacuum pump. He took the gas, he reduced the pressure. Okay, after doing that, what exactly was the finding? Can you see that the cathode rays, can you see this black arrows going towards anode? Just look here very nicely. You see that the black arrows are exactly going towards anode. Means the perforated cathode were releasing perforated cathode were releasing cathode rays. So these cathode rays started traveling towards anode. These cathode rays started traveling which side beta? This cathode rays started traveling towards anode. Now in return some anode rays are also coming out, and these rays were trapped in this part. In this portion anode rays has deflected some light. The fluorescent light has been shown here. So this is exactly the anode rays. I hope you might have understood. Cathode got trapped in this part. Cathode rays started going towards anode, and anode rays started coming, and the anode rays were trapped in the opposite side of anode. You see here, opposite side of anode we have seen the anode rays. Understood this point? Now we are going to discuss what is exactly these anode rays are about. Understood? So we are going to understand about it now on applying high voltage. So there also in the discharge tube we have applied high voltage. Okay. Now between anode and cathode it was observed that fluorescent was observed on the glass wall of the tube. So look here, we are exactly talking about cathode ray experiment. When we did cathode ray experiment now, that time we see that cathode rays were emitting. Now only Sarthak, 5 minutes. Hardly 5 minutes. It's time. I am going to start your class now, Sarthak. I am going to start your class. Take a note and start writing the important questions for coming examination. From today only final revision we are starting. So now look here beta. So we have understood another important point here, and that important point that cathode rays were emitting light, and we have trapped in the previous experiment. We have seen that light has been exactly, the fluorescent were trapped, and the fluorescent were exactly seen which side? The fluorescent were seen, see, the fluorescent were seen this side, the color opposite in the direction of anode. We have seen that cathode rays are emitting light. Cathode rays are emitting light. Okay. I am going to keep it till here beta. The evening I am going to discuss about cathode rays and anode rays. I have to start class 10th class. It's time now.